Hey guys, today we're going to continue talking about the quotient property with exponents. So remember, the quotient of powers property says that when you're dividing powers with the same base, we subtract the exponents. So I have an example here. Notice how they're both a, so that means that they have the same base. So that means I can subtract their exponents, m minus n. So always whatever's in the numerator, subtract what's in the denominator. For today, we're going to have exponential expressions with coefficients. So when that happens, you do divide the coefficients, just normal division, and then you simplify the variables using the quotient property from up here. So let's look at our first problem. We have x to the 6th, y to the 8th, divided by x to the 4th, y to the 3rd. So here we want to combine the exact same variables, so the letters that are the same. So we're going to combine x to the 6th and x to the 4th. And since we're dividing, that's the quotient property, which tells me to subtract those exponents. Okay, and then the same thing for the other one. I have y to the 8th and y to the 3rd. So quotient property tells me I need to subtract those exponents, 8 minus 3. So now let's just go through and simplify everything that I have there. X to the 6 minus 4 is 2, and y, 8 minus 3 is 5. So this would be my final answer. Okay, let's look at our next problem. 6p to the 5th, q to the 7th, r to the 3rd, divided by 2p to the 3rd, q to the 6th, r. So just as before, we're going to combine the same variables with each other. But first, this one does have a coefficient. See these numbers out front? So they're not letters, so they're not variables, and they're not exponents because they're not small, so they are coefficients. So when you have coefficients, you're still going to divide them like normal, 6 divided by 2. But now let's go on and look at the variables. P to the 5th power divided by p to the 3rd power. Quotient property says I need to subtract those exponents, so 5 minus 3. Then I have q to the 7th power divided by q to the 6th power. So same rule, we're going to subtract those exponents, 7 minus 6. And then I have r's, r to the 3rd power divided by r. So notice the one at the bottom, there is no exponent there. So if it doesn't have an exponent, it's just an invisible 1. So for r, we're going to have 3 minus 1. So now let's just go through and simplify everything that we have. So starting with 6 divided by 2 gives me 3. And then I have p to the 5 minus 3. 5 minus 3 is 2, so that would be p to the 2nd power. Next for q, I have 7 minus 6, so that's to the 1 power. And then lastly, I have r. 3 minus 1 is 2, so that'll be r to the 2nd power. And then just something that I want to mention is, see this q to the 1 power? Anytime your exponent is 1, you don't need to write it, because we know that when there's no exponent, there's invisible 1. So your answer would be in that form. 3p to the 2nd power, qr to the 2nd power. Okay, let's move on to the next one. 12a7b2c9 divided by 3a4b6c7. So let's take it one thing at a time. Let's look at those coefficients. So I'll have 12 divided by 3. Okay, and then now for the letter A. I have a to the 7 divided by a to the 4, so we're going to subtract those exponents, 7 minus 4. Now for B. B to the 2 minus 6. And then last we have C. So that would be C to the 9 minus 7 power. So now let's go through and simplify everything that we have left over. So starting at the beginning, 12 divided by 3 is 4. Then I have a to the 7 minus 4 is 3. B. 2 minus 6 gives me -4. So make sure you write that negative sign. And then C to the second power. So this is already correct, but there's another property that I need to use here. Anytime that you have a negative exponent, so right here that B has a negative exponent, you can move it down to the denominator and change that exponent into positive. So what's going to happen here is the 4, A cubed, C squared, all of those were positive exponents, so they get to stay where they're at. But the B, since that one was negative, is going to move down to the bottom. So this is my final answer. Okay, let's move on to our next example. 2d e to the fourth f to the 11 divided by 8d to the third e to the second f to the seventh. So let's start with our coefficients. I have 2 divided by 8. Then next are d's. And here's another case of this one didn't have an exponent, so it's invisible 1. So it'd be 1 minus 3. Now our e's. So it would be e to the 4 minus 2. Then f. So f to the 11 minus 7. Now let's go through and simplify everything that we have here. So 2 over 8, we can simplify it, but it's not going to be a whole number. It reduces down to 1 over 4. Then d, 1 minus 3 is negative 2. E to the positive 2, f to the positive 4. So just like the previous problem, we have a variable with a negative exponent. So that variable is going to need to move to the denominator. The cool thing about this problem, though, is that when we simplified our coefficients, it was a fraction. So we already have a denominator. See how that 4 is at the bottom? So when we write this down, I'm going to start with that fraction. So my coefficient was 1/4. There's my 1/4. Then e was positive, so e to the second, and f was a positive exponent, so f to the fourth. D was a negative exponent, so d is going to go to the bottom. And now that it's at the bottom, it doesn't need to be negative anymore. One last thing is that I'm sure you've noticed by now, anytime something is 1, so a coefficient of 1 or an exponent of 1, you don't need to write it because it's implied that it's there. So I'm going to erase that 1. And this would be our final answer. Okay, so now I have one last example. We're going to look at a word problem. So when we're dealing with exponents, our word problems are going to be dealing with area for the most part. So this one says, the area of a rectangle is m to the 8 n to the 7 p square inches. Then it says, if the length of the rectangle is m to the third n to the fifth p to the second power, what is the width? So you have to picture this in your brain here. If this is my rectangle, and I already know that this is the area, and I also know that the length is this part right here. So M3, N2, P. So I'm sorry, it was N5, P2. Let me fix that. Now they want to know what is the width. So we already have the long part. We have this part. But they want to know this part here. What is that equal to? So what you need to remember is that the formula for area of a rectangle is length times width. But if I already have area and I have length, I can rearrange this to area divided by length is going to be equal to width. So that's the formula that we're going to use. So starting with area will go on top. And divided by the length. Okay, now we'll just do this problem the same way we did all the others. So let's combine our m's by subtracting those exponents. So that would be m to the 8 minus 3, which gives me 5. Then our n's, 7 minus 5, which gives me 2, so n to the 2. And then p. The top one doesn't have an exponent, but the bottom one is 2. But we know no exponent means invisible 1. So 1 minus 2 is negative 1. So there's my answer there, but I have the problem of having a negative exponent. Anytime you have negative exponent, it needs to move down to the denominator. So I can rewrite this as m to the 5th, n to the 2nd, over p to the 1 power, but we don't need that 1, so I'm just going to leave it as p. And that is our final answer. Okay guys, these were our notes over the quotient property of exponents, and I will see y'all again tomorrow.